Hello, Algebra 2 students. I appreciate you taking time to get your notes taken care of. Today we're going to take the next step in the progression and look at the inequalities and the exponential function. Please copy down the title as well as the objective. Our objective for the day is to learn to determine how an inequality affects the solution set for an exponential function. Now this one's not going to be too bad. If you have understood the inequalities really at all, then working with the exponential function, there's really nothing to it, no real tricks involved with it or anything like that. As always, anytime you need more time to get something copied down, please press pause and then hit record when you're ready to move on. Okay, so let's take a look. Now we're going to start off basically looking at an equation of an exponential function, just like we always have with these. Okay, and we have learned plenty of times by now, so hopefully what you're looking at this point is no great secret at all. Any point that exists on a graph is a solution for the equation that goes along with that graph. Okay, so obviously for this equation, y equals the negative of 1/2 raised to the x plus 3 plus 2 has an infinite number of solutions because there are an infinite number of points that exist on this graph. I have shown you 4 of them, but that by no stretch of the imagination covers all of the points that are on there. So there's an infinite number of points. You're looking at a very small selection of them. Okay, but all of these points, x comma y, that exist on this graph is a solution for the equation. That means you could plug any one of them in there, any of the x comma y's into the equation, and it would make the equation balance. Now, as we begin to look at inequalities, as always, okay, when you look at an inequality, now the inequality basically uses the graph as a boundary of two different sections of space in the graph. Okay, so when they say something like y is greater than or equal to this equation, okay, then we have separated all of two-dimensional space into an area on one side of that curve and an area on the other side of that curve. And now it's not just the curve that becomes solutions, but also any x comma y that exists in the space that the inequality is referring to. Those become solutions to the equation as well. Now, a lot of the same rules and procedures that we had have had for the last 3 units still are in effect. Okay, so the same ways to manage inequalities still apply. Now, this is the way it tends to happen. Either we have a variable already isolated, and that makes life very, very simple. If there's a variable already isolated, you can simply shade in the direction of that axis according to which way the inequality is positioned. Very nice when one of the variables is already isolated for us. Okay. One of the things you might have noticed is that for the other 3 units where we've done these inequalities, right here, these 2 graphs that we've looked at, one of them has said y and then some type of an inequality to go along with a graph, and then the other one has said x and then some type of an inequality to go along with the graph. You may have noticed that we have not spent any time at all this unit talking about inverses, and that's where we kind of got to, where one of these graphs had y isolated and the other one had x isolated. Okay, one being the regular function and the other one being the inverse. We have not looked at any inverses for this function because you might remember that the inverse of the exponential function is actually the logarithmic function, okay, which is our next unit that we'll be getting into. Okay, so we're not going to run into any inverses as far as the exponential function is concerned just yet. Okay, but anyway, coming back to what we're talking about now. Okay, when the equation says, as the one on the left shows, y is greater than or equal to negative 2 to the x minus 1 plus 4, then again, all you have to do is ask yourself, okay, where is the larger values of y? Where is y greater. And of course, y is greater going upward. Okay, so everything that is above this equation will be shaded. And of course, keep in mind that the domain of this graph does not ever continue expanding. It not only goes infinitely to the left, but also infinitely to the right. So do not stop shading simply because the graph or the curve of the graph is off of the plane. Okay, go ahead and shade in the rest of the graph going to the right. And then here on the left, y is smaller. I'm sorry, we're on the right side now. Y is smaller than or equal to 1/4 to the x minus 1. Okay, well, the variable is already isolated. All you have to do is ask yourself, where are the y values smaller? And of course, the y values are smaller going downward. Okay, so we can shade underneath the graph. Okay, and once again, this graph does not stop continuing to expand to the left. It will cover the entire domain, which means we can continue to shade out there to the left side. Don't leave that part of the graph blank because it is part of the solutions. Now, of course, those are like I said, the easy way to do it when one of the variables is already isolated for us. Now, hopefully, if the variable is not isolated, then we will be able to isolate one without too much difficulty. Okay, but if you run into, as always, if you run into an equation it's just too difficult to isolate a variable, or you're not confident in your ability to isolate a variable, you can always pick a test point in open space, plug that ordered pair x comma y into your inequality, and then simply read the inequality after you've plugged that in. If you end up with a true statement, as always, that means that the inequality does like that point, so shade towards that point. If you get a false statement, then that means the inequality does not like that point, and shade away from it. Okay, so let's take a look at a couple of specific examples here. Okay, let's say we're looking at an exponential function y is greater than 2 to the x plus 2 minus 1. Well, we're going to begin the same as we have begun here for the last several days. We're going to figure out what our starting point of our graph is, and then we will determine which directions the graph will be moving so that we can pick appropriate values for x in the domain, and then plug in and get our values for y, and that will give us the shape of our graph. Then we can read the inequality, decide if we want to draw a solid line or a dashed line, and then we will shade. Okay, so let's take a look. Let's see where the vertex or starting point of our graph is going to be for this particular equation. The first thing to do is determine whether the graph is right side up or upside down, because that'll be the difference between it crossing the y-axis at +1 or at -1. Okay, well, hopefully looking at the equation, you can very quickly determine that the graph is right side up. The base number is positive. It's +2. Okay, so we are right side up, so this graph would want to cross the y-axis at +1 unless hk moves it. Okay, and as we can see, we do have an h value. Okay, the h value is a -2 up there in the exponent, and the k value is -1. So that's going to move our vertex or starting point. It's going to move it 2 units to the left and 1 unit down. So that would move it from 0, 1 on the y-axis to -2, 0, which happens to be on the x-axis. So there's going to be our starting point, -2, 0. Now from there, we need some x values to kind of complete the shape of our graph here. So we need to figure out which direction as we leave -2, or as we begin at -2 on the x-axis, is it going to the left that's going to be the vertical side of the graph, or is it going to the right that's going to be the vertical side of the graph, because it makes a difference on how far we space our x values apart. Look back at the equation. We have a base number of 2. That is kind of what not necessarily the parent function, but it's kind of the most common parent function. That's the one that is horizontal to the left and vertical to the right, and I don't see anything else in the equation that's going to change the fact that it's horizontal to the left and vertical to the right. Okay, so as we leave -2 on the x-axis, going to the left, we would want to take whole steps because the graph is not changing very much vertically. But as we go to the right, we would want to take smaller steps, probably half steps, because of the vertical change in the graph moving away from that center point. Okay, so whole steps to the left and half steps to the right. And as always, we will take these values one at a time. We will plug them into the equation one at a time and get the values for y. Quick reminder, those of you that have been kind of trying to cheat your way to right answers on the calculator, keep in mind that test has been absolutely kicking your teeth in. And it's been kicking your teeth in because you don't know how to plug values into an equation. So please, let's get some practice on this. Take -5, plug it in for x, and find out how big y is. Then do the same for -4, and then the same for -3, and so on. In the end, we arrive at these decimal points, so we end up with 7 ordered pairs here. Those ordered pairs will turn into points in our graph, and then our graph will, or our points in our graph will turn into the curve to go along with our exponential equation, exponential function. Okay, so should we draw this line, okay, with our inequality, should we draw it a solid line or a dashed line? Okay, we'll look back at the equation and look at the inequality. Is it an equal inequality or a non-equal inequality? This one happens to be non-equal. So when we draw our line, we will draw it dashed to represent that this is the boundary that our graph is dividing the grid into two pieces. That's our boundary. However, this line, this curve is not included as part of the solution. Any point that exists on this graph will not solve the problem. Okay, and now we just need to decide, okay, which direction do we shade from there? Well, the equation says y is greater than this curve. So where are the greater values of y? Of course, the greater values are upward. So we would want to shade everywhere from this graph going upward. Okay, and don't stop there. The graph continues to drift rightward off of the bottom of the graph. Okay, because as we know, the exponential function covers all values in the domain. Let's look at one more real quick. This time we have y is less than or equal to the negative of 1/3 raised to the x power plus pi. Now I know what some of you people are thinking right off the bat, freaking out because we see that pi sitting there. Well, what does it change? Okay, what's different about the equation because of the existence of pi in this equation? Well, there's no difference. Pi is simply a number, and it is currently sitting in k's position. This is a vertical shift. It just so happens that our vertical shift is going to be equal to the value of pi. Okay, so once again, we're going to figure out the beginning point of the graph, the vertex, if you will. Okay, and then we will pick some appropriate values in the domain going each direction, plug them in, get our values of the range, and then complete the graph from there. Okay, so where does this graph begin at? Okay, first thing you want to do is decide, is the graph right side up or is it upside down? This particular graph is upside down. That's important to know because that means this graph wants to cross the y-axis at -1. Okay, the only thing that can stop it from crossing at -1 is if the graph is moved by h or k. Now looking at the equation, hopefully you can see that there is no h value. Nothing is being added or subtracted to x, so no phase shift, no sideways movement. Okay. However, as we already said, we have a vertical shift, happens to be in the amount of pi. Now, of course, we should know by now that pi is 3.14158.265, blah, blah, blah. It's an irrational decimal point, never stops, never repeats. Okay, for simplicity purposes, we'll just say it is 3.14. Okay, so from -1 on the y-axis, we are going up 3.14, which would put us at positive 2.14. Okay, so there's our starting point. Now let's look at the equation and decide, as we move to the left from this location and move to the right from this location, which side is the horizontal side and which side is the vertical side. Okay, well, we have that negative in front of our base number. That tells us that the graph is going to be upside down, which we already knew that. And then our base number is 1/3. Well, 1/3 is a number that exists between 1 and 0 on the number line. And remember, when you get a base number between 1 and 0, that's going to turn the graph around backwards. So instead of going horizontally to the left and vertically to the right, that's going to turn it around and make it go horizontally to the right and vertically to the left. Okay, nothing else in the equation looks to be changing the direction. Okay, so that means as we leave 0 going to the left, that's the vertical side. We will want to take small steps going to the left from 0, but as we go to the right from 0, that's the horizontal side. Not so much change on that side, so we'll take whole number steps. So again, small steps coming to the left, big steps going to the right. Once again, we take these values, we plug them into the equation one at a time in place of x. For every value we plug into x, we ought to be able to get a value for y, and we end up with these decimal points. Using these ordered pairs, those ordered pairs become points in the graph. Now we need to decide, are we going to draw a solid line this time or a dashed line? Okay, look back at the equation. Do we have an equal inequality or a non-equal inequality? This time the inequality is equal, so that means that the curve will be included as part of the solution, so it gets a solid line this time. And we need to figure out which direction to shade. Well, let's read the inequality. The problem says y is smaller than or equal to the curve. Okay, so where are the smaller values of y? They are downward. So underneath this curve, we will shade towards the smaller values. Okay. There's not a whole lot to the inequalities when it comes to the exponential functions. Not really anything new or any crazy tricks or anything like that. Pretty straightforward stuff. Okay, so I hope you understood this one pretty simply. I appreciate you finding time to get your notes taken care of, and I'll see you in class.